SpongeBob SquarePants. 6.3 Radical Operations. That sounds kind of cool, radical operations. But radical just refers to the radical symbol, and then operations is just add, subtract, multiply, and divide. Let's see what we can do. Adding and subtracting. Expressions can only be added or subtracted when the roots and the radicands match up. Here's what I'm talking about. So you have to make sure the roots are both the same and the radicands are both the same. So if they're both the same, then you can add or subtract. So let's look at this example. 5 cubed root of 4 minus 2 cubed root of 4. All you have to do is evaluate the 5 minus the 2. And you have 3 cubed root of radical 4. So the cubed root of radical 4 acts kind of like a common term. It's like you're adding up common pairs. Okay? Notice this one. This one, they both have 5x in the radicand as the radicand, but this one is a cube root and the other one is a square root, so when that happens you can't simplify. Same thing with this one. The roots are both 4s, so that's good, but then the radicands are different, and so you can't combine them. Alright, so you have to make sure the radicand and the roots match up before you add or subtract. Tricky. Sometimes the different radicands can be made the same. Like this one. Notice they're all square roots. So square root, square root, square root. That's good. But the radicands are all different. One's 12, one's 75, one's 3. You can't combine them unless you simplify first. Simplify the square root of 12, you know, with the whole breaking it down. Simplify the 75, break it down. The 3 can't be broken down, so that cannot be simplified. But when you do simplify first, you have what looks like this. And now you notice the roots are the same, square root of 3, square root of 3, square root of 3. Now you can combine them. 1 plus 5 minus 1, because that's a little bit tricky. There's a minus 1 right here. So that gives us 6 radical 3. Here's another one. These are cube roots, cube roots, cube roots, but the numbers on the insides don't match up. But you can make them to match up by simplifying them. Remember, in this case, we're looking for triplets. The last example, we're looking for pairs. Now we're looking for triplets. Break it down. Look for triplets, look for triplets, look for triplets. We get this. Alright, now they all have cube root of 2's in them. So then you just do 5 plus 3 minus 2. And the final answer is 6 cube root of 2. Alright, that's almost like combining like terms. Alright, let's do some multiplying. With multiplying, the radicands do not have to be the same. The roots have to match up though. Alright, so multiplying these guys, you have to do FOIL, first, outside, inside, last. This is what you get. Let's look at it a little bit more carefully. When you do 3 times 5, that gives us 15. 3 times radical 7 gives us 3 radical 7. negative radical 7 with the 5 gives you negative 5 radical 7. And then negative radical 7 times positive radical 7 is negative radical 49. Okay? Simplifying it. These two you can combine. A 3 radical 7 minus a 5 radical 7 is a negative 2 radical 7. And then this one, a radical 49 is just 7. And then to get the final answer, you just combine these two, the 5 and the minus 7. Final answer is 8 minus radical 7. Let's do another one. Foil this. You should get this. 4 times 5 is 20. 4 times 4 radical 2 is 16 radical 2. The 2 radical 2 times 5 is 10 radical. 10 radical 2. I think I said that wrong. I said 5. And then this one is 8 radical 4. You just multiply outside with the outside, the inside with the inside. It does simplify a lot. You can combine these two middle terms, just like you can always combine the two middle terms to get 26. And then, well, I guess I'll show a little bit of work. Radical 4 is just 2, and 2 times 8 is 16. And then from there, you just combine these two terms. Final answer, 36 plus 26 radical 2. All right, kind of tricky. It's not the easiest thing to do. All right, dividing. Now, dividing is almost like multiplying, but there are some rules. There are 3 things you cannot have in the denominator. You cannot have a 0 in the denominator. You cannot have an imaginary number in the denominator. And of course, you can't have a radical sign in the denominator. And so when that happens, you must rationalize by multiplying the numerator and the denominator by the conjugate of the denominator. All right, so here we have some radical signs in the denominator. Remember, the conjugate is radical 5 plus radical 2. You just change that sign, and you multiply it to the top and the bottom. It might help if we put some of these things in parentheses. It might look a little bit clearer. The top one, you just distribute this into here. But the bottom one, you have to FOIL, just like we did in the last example. And that's what you get. 3 radical 2 times radical 5 is 3 radical 10. And then 3 radical 2 times radical 2 is 3 radical 4. And then the bottom you just FOIL to get this thing. And the way the conjugate works is that this term and this term will always cancel each other out. And then this term and this term will always be perfect. All right, let's simplify it. Here's 3 radical 10. But then this one, radical 4, we all know radical 4 is just 2. And so 2 times 3 makes the 6. And then the bottom, radical 25 is just 5. These cancel out. Radical 4 is just 2. And so that's where I got the 5 minus 2 from. And simplify. We get 3 radical 10 plus 6 over 3. And then here's one last thing. If all 3 of these can be reduced, go ahead and reduce them. And then it becomes radical 10 plus 2. This just turns into a 1 and a 1. All right, there's our final answer. That's a little bit complicated. Let's do one last example for the day. Same thing, we have a radical in the denominator. So you multiply the top and the bottom by the conjugate of the bottom. So I just change it to plus 7. If it helps, put them in parentheses. The top you just distribute. The bottom you have to FOIL. That's what we get. Remember, with the conjugate, these always cancel out. This always is perfect. And this is already perfect. It doesn't even have a square root in it. So simplify it more. The way I got 20 is just 5 times 4. And that's our final answer. There it is. Go ahead and take a stab at the homework and see how you do.